Welcome to the openIMIS presentation. In this video, we'll go through the modular architecture and specifically the backend. This video will show you first how to set up your environment, how to create a new module, and how to add a new model and expose it to GraphQL. To set up the environment, there are a few prerequisites. We then create the virtual environment, do a git clone. We'll start the Docker components, mainly the database. We'll start the server, install the development environment, query the GraphQL. The prerequisites are first to have Docker installed. This setup depends on your operating system. If you don't have Docker and want to use directly a SQL server, that is possible too. The procedure is very similar. You can use GitHub to download the files as a zip, but we recommend to use Git. There's an editor, you can use an editor or an IDE like PyCharm or Visual Studio Code to edit the files. Then we have also the requirement for Python 3.6 or newer. So we'll first download the various projects. So the main ones are the backend project, that's going to stick them all together. Then we have the database, Docker, that's a SQL server mostly. And optionally, we can use the list Docker that contains all the other modules that might be useful. Then we'll create the virtual environment. We're going to start the Docker component. So we follow the instructions in the readme.md, create the image with the password, create a .env in the backend with the password, select the database URL to fetch the pre-existing data, and then create the database and migrate. To start the server, we'll follow also the instructions from the README. We'll migrate, it should be probably done in the previous step. We'll encounter an error and see why it is and how to do it properly on development. We create a super user. Then we'll show that we have a /API, access the admin part, and the GraphQL. To set up the environment, we'll set up PyCharm. We'll select the Python SDK, create a rendering configuration, encounter the same errors as previously, and create the environment variables. And then we'll do a little bit of debug. I'll show you also how to use GraphQL, how to access it, and how to do some queries with it. So we're going to need three main modules from GitHub. So the first one, just go to github.com openIMIS. There are a lot of repositories. You have 62 repositories. This includes the .NET system. This will include the front end and also the backend. So we're interested in the backend. You can just do a search on backend BE.py. So you see that this is the openIMIS backend assembly reference. You have here the source code. You see that the README is explaining how to install it. We're going to go through this, but first we're going to check the code. You can download the zip here, or you can just click the URL. Then you can just switch to your terminal if you want. So in this newly created folder, I can just do a git clone with the address I just copied. This will quickly retrieve this module. Then we can go back to openIMIS and open it in a new tab. And we can just use the database. So in the database, we're going to copy the address again and just do a git clone of it. There we go. We're going to start with this one. So in the configuration, we can see here that there's a more detailed wiki page containing all the current versions of the various scripts and so on. And this is the command we're going to use, but we need to go to the wiki first. And we need to choose which database we're going to use. So we can see here the configuration, but you can see that you have either an empty database or a demo database. And this is version 142. So we're going to use the demo database in this case. So we can go back here. And we'll have it in this command. So let's switch here. The first thing we need is to use a password for the database. This needs to be a strong password, otherwise it will not start. Let's say blue square 2020. Then we need an address for the script to create the database. So in this case, I'm going to paste what I had in the wiki, and I can just execute this. You see that we have accept and use a license agreement equals yes. So you should only do this if you really accept this license agreement. This was fast because it was already in cache on my system, but otherwise it's going to download the full SQL server. Now that we have created this, we can actually start it. So we have only created the description here. So we can just run the script. If we do this, we will see scrolling in the terminal the various creation commands from this startup. This is ready. Thing is that my terminal is now locked. What I can do is just hit Ctrl+C. It's going to stop the database. So I can run the same command again, just with -d, so that it doesn't attach to my terminal. Now we can see that the thing is running. You just do a docker ps. From the command line you can also do a docker logs and use the ID of this container, and you will see exactly the same result. Now we still need to create the database. So if I go back to the description here, you can see containerless. We have docker exec. So we're going to execute within this container the /create database script. So in this case, I'm taking container ID, docker exec, my container ID, /create database.sh. However, see, if I'm checking the version of Python that is installed, I can see it's Python 2.7. But I do have Python 3.6 installed, which is what I want to use by default. So I want to create an environment that will be using Python 3.6, and that will be with its own libraries, isolated from any other. So to do that, I can use various libraries, but in this case we're going to use Python 3.6 with a module venv, and we're going to create a folder named venv. It could be any other name. So this is going to create a folder with the storage for this specific virtual environment. But it didn't do much more. If I just run it like this, I do Python minus version, I still use Python 2.7. Now to use the virtual environment we just created, I need to source venv bin activate. And this is going to integrate all the various variables and all the parsers and so on that I need to run this specific version. You can see it in my prompt that I'm using this virtual environment. From this, we have now these virus modules. So now we have installed our database, we have our backend, we have our virtual environment. Now let's try to run the backend, but first configure it. How do we do that? Let's go back to the openIMIS backend readme. So we have cloned the repository, we've installed Python, we have recommended a virtual environment, we have pip. Within the backend directory, we're going to install sub dependencies. We take the requirements file. Based on that, we're going to download the various packages. In this case, it's pretty fast because it's already cached as well. At some point, on some systems, if the SSL library is not properly installed, you will have an issue with the compilation of the Psycho PG2. As I have here. To avoid that, we can actually switch the requirements to use a binary version. So just add binary, -binary in the dependencies. Just run it again. So in this case, it's going to be using a ready-made version. As you can see also, we're using pip version 9, while version 20 is available. It's a good idea to actually upgrade. Now we also need to generate from, if we take a look at the openIMIS.json file, we have the list of the various modules that we're going to use, each with their own version. They will be by default downloaded from PyPy as well. To generate the dependencies from this configuration file, it's used in many places, we're actually going to use this modules requirements script that's going to take this openIMIS.json file and generate the module requirements. It's pretty fast. These are the module requirements that we have here. Now we're going to actually install them. There we go. And we need to configure the database connection. So to do that, I can just switch to the corresponding section. So by default, openIMIS is connected to a SQL server. It can be via ODBC, via TCP/IP protocol, or directly via SQL server. We're going to do that by creating a .env script. If you saw in the database section when we went to the wiki, it is also explained here how it is created. This one has more on the configuration settings, but for the moment we are going to use mostly these DB host, port, name, user, and password. So in this case I'm going to create a .env file. So the host is localhost, because we want to use our own machine in this case. If it's running on a different server, well, you have to adapt this, of course. If you're running within the Docker environment, you're going to use database because it's the host name of the container that's running. But in this case, we from the machine, so we have exposed the port to the whole machine, so we can just use localhost. We have the database name. It's normally IMIS. Then we have the user, that's SA, system administrator. And then we need the database password that we just created earlier. It was created 2020 in this case. That's it. Now let's go back to the setup. So we configured the database connection. Now we can start openIMIS from this sub openIMIS folder. Python manage run server. Here we can see that we have a bunch of errors. It's because it's not finding the tables, and it says that we have 49 unapplied migrations. So that is actually real. So to do that, we need to run the manage.py and just do migrate. So these first errors are just normal. It's the first time. And we have now created all the various tables that we needed. So now if we go back to run server, we have this error saying that we have no static files folder. Normally it should have been created. We just created. It doesn't affect the server running. Now that it's running, we can check that we can indeed access. We can do a localhost 8000, and there's no resource found on the server, which makes sense because we don't want any home page on this backend server. So what we're going to do is try and access the admin page, for example, and we have an error of 500. Why is that? It's actually because we have a kind of production server and it's not ready to use this way. So if we check into the main folder here, we can see that there is a devlaunch.sh. If we look at the devlaunch, we can see that it's sourcing the activate, then it's going to the openIMIS folder and it's setting a number of variables. So the site root API, remote user authentication true, raw security false, debug true, and then do the run server. If we actually launch this, it's okay for the Venv activate, it's not in this folder. And now it's running again. And if we go this, you can see that there's an error. But we said that we had /API/admin, and now we can access. However, what are we going to do there? It's not possible. So what can we do? We need to have a super user. To have that, we can just run the Python manage. We need to go back, of course, to the openIMIS folder. Just run Python manage, and you can create super user, find a decide from a username, okay, we have a super user created. So let's start the server again. And now if we use this, we have access to the admin situation. So here we have not so many places. We have technical users, we have the module configurations. But there are no module configurations in this case, but you could add one. Now, something else that you can do is to go to the GraphQL endpoint. And this gives you access to a nice interface that is only available in the development mode. to access the GraphQL interface, for graphical it's called, and you have a lot of help to write your queries. So now if we start the PyCharm, first start you will say that there's no configuration to import. So I just open the folder with all the projects in it. From here we can just already browse the code itself. From here we can just browse the code, so in this case we can go and see the settings files, all the schema. You see that there are a lot of errors. This is because we didn't configure the SDK, so it doesn't know where exactly to look for these files. So here you can see that it doesn't know where to look for the files we have here. So if I go to my menu and I go to preferences, the location depends of course on having a Mac or Windows or Linux. In these preferences you have the project openIMIS, and you can see that there's a Python interpreter, and this default from my system. We don't want that, so we add a new one, the add, and here it automatically detected that there is a new environment, and I want an existing environment because it's not a new one. And you have to specify where the interpreter is. So in this case it's in my dev openIMIS, and you have to go all the way to the Python executable, so in this case Python. There you go. Just say OK. It automatically detects all the modules we have installed. So it's now going to update skeletons, see how it's working. So now it is started. I can go to the add configuration. I can add a new one. Here, if you have the pro version of PyCharm, you will be able to have Django. In this case, I'm going to select the script path. I'm going to select the script. So I go to the openIMIS folder, take the manage.py, there we go, and let's just say parameter run server. So we have here the SDK that we just created, and just say OK. Should name it with run server. Okay. So now you can see that the references are now defined. If I stop it from here, just do a Ctrl+C, go back to PyCharm, and I can just run it on the debug mode. And see, we have the same result. What we can do, however, is in this case we can just put a breakpoint. So let's say that we have some specific configuration over here. We can just put a breakpoint here, and if I restart the application, this is in settings, and we stopped there, and we can just see exactly what is going on. So I can just check exactly what are my installed apps are. Now that the server is running, we can remember that originally when we started it, it was just not working because we had an error 500. So what we can do to solve this is, since we cannot use the dev launch in this case, And it's only about adding some environment variables. You can just edit the configuration, and we have here the environment variables, so we can just go back to def launch and just copy the same variables. So then we can just add these environment variables like this. So the site root /API to avoid confusion in the gateway, remote user authentication true, host security false, and debug true. If I do this, and then start my development server again, I will now be able to access the various pages on API/admin, of course, and API GraphQL. Be careful not to use the trailing slash on GraphQL, it's just GraphQL with no slash. So how does this so let's have a quick introduction to this GraphQL language. So you can see here we have some example of what we can do. You can actually go. So let's dig into the GraphQL interface. We can first check the documentation. You will see that we have two types of operations. These are queries and mutations. Queries are obviously to read data, and mutation is to update this data or to create one. There is also normally in GraphQL a notification part, but we don't use that. If we go to the queries, we can see that there are a number of objects that we can filter and try and find. So if we take the claims, you can see exactly what is defined in the claim object. So if we start, we can open curly braces. And something that is really useful is to do a Control-Enter, and will show you exactly what you can type in this place. So we're going to select the claims. Claims then requires you to, it's in red, so it says that it needs some selection subfields. So normally if I want to see what I have to, what I'm going to show, I can see these data. So everything is paginated in these objects, so you can have the page information. The page information itself is a sub-object, so you can see what exactly is inside. You can see if it has a next page, and where's the start cursor, for example. Then next to it you have the total count, so that's the total amount of data, and not just for the page. So we have the edge count, which is exactly how many rows we have in this specific page. Then we have this edge. Inside that we have the node and the cursor. The cursor is really where we are going to move through the pages. So here we have the node. And the node is actually the claims object, where we have all the data that we're trying to show. So in this case we can show the ID, the UID. We can show, this is going to be, we have a category. We can show the injury, and the injury itself, as you see, is a sub-object. And we can show the last name and the other names, for example, and the ID. You can just hit Command Enter or Control Enter, and or just click the run here. If you typed everything on a single line, you can do that too. Of course, it's a bit less readable when you have been typing as you want, so you can just do a predefine and it will be showing everything nicely. So in this case, we have total 10 items in the page, total 10 in this page and in total, so there's no paging on this line. And you have the information for the next page is false, and we started with this cursor. These are the various objects we have inside. We have the ID, the UID, category is null in this case. We have the insurer, it's Elena Doni, Elena Etu. This ID is actually base 64 encoded data. GraphQL does not use just the simple primary key in order to be able to know which object it's trying to represent. It can you can just base 64. You'll see that it's claim GQL type 3, so it is a claim and it's the ID number 3. You can also, this is just getting the list of claims, but you can also add some filtering. Now if we want to add some search criteria, we can just add it to the claims. So we use braces, and we have the, against for example, we have a status and want the status to be 1. Just execute this. We see that there's only 1 in this case, and we can have multiple parameters, so there are quite a lot. You will see also that there's difference if we look for something from an insurer, for example. I want an insurer last name being listy. So in this case we'll have the same results, and we have double quotes. You still have the same results, of course, but if we remove the status here, we have the more complete list. This is not having the insurer parameter here is not really the standard way of doing for GraphQL. This was done for reasons of the modularity. It should be able to change in the future, but for now we have all the subparameters that are included in here. You also have a special parameter, that's the order by, and you can say, for example, that you want to order by, in this case we can order by FALJ, we can order by insurer, other name, and you see that you have AJJ and then later the L. So if we take a large query like this one, we have a lot of items, we have 257, and we start with the acetyl salicylic acid. We can say that we don't want that many, so we only want the first 5 rows. This limits it quite strongly. We have the edge count to 5 and still the total count to 257. But we can have also additional information. We can check the page info, and page info we have the has next page and the end cursor that we need. The has next page is true in this case, of course, and we have the end cursor that has some value. If we add this in the after parameter, we'll get everything that is after that. We have no acetyl salicylic acid anymore. We only have 5 rows, and we can just go around just copying these items. And if we reach the end, we'll have has next page false, and probably 5 or less items in this place. This is how we do the paging here. Now that you have seen these objects, and if you want to see how they're defined and how we can extend them or change them, if you look at the code, well, there's not much in here. We don't see these details. If you look at the openIMIS.json, we see that we have a number of versions for the modules and generated the modules requirements. So we downloaded a ready-made bundle for all these items. What we want to do in this case is not to use the bundled version, we want to install the actual module. So to do that, we come back to the GitHub, and we see here to edit an existing module, and we have to get the modules like we have over here, and we have to do the pip and install to remove the version we have here, and then install our own version. So let's go to some GitHub repository, and if we decide to retrieve the claim, for example, we have claims front end, the claims backend, claim pi. This is what we want. So again, we just copy the address, switch here. Be careful, we don't want to do it into the backend folder. We have to go at the same level as the openIMIS backend pi and just clone the repository. Now we can go into this directory. Here we'll have all the details here. So what we can do now is to follow the instructions from this. We need to do the pip uninstall claim. And then we say from this is supposed to be run from the backend, but it doesn't matter, it's a pip command, so this pass works. And now we have no big difference except from the egg info that is over there. Now if I restart, if I come back to my development environment, you can see that I have a new module here, and I have in this module I have all the models, the queries and mutations corresponding to it. We'll get to it in a second. And if I go back to, if I check my server here, normally it should have restarted, but we'll make sure that it's properly restarted this time. And if we go into the server details, and we can check the claims, ID, status, category, injury, name, last name, other names. You can still do the predify to make it clean. So if I run this, it's still working. But let's say that we want to add a new ability to search here. I want to search, I don't know, for the category, for example. There's no search for category. So in order to do that, we can move to the module itself. If we check into the models, we'll see here that we have the claim admin, claim feedback, and if we just check the structure, we can see that we have all these claim objects, claim related objects, claim service, the feedback, and so on. So if I'm on the claim itself, I can see that we have a category here, but we're not able to search for it. This is the actual database object. Be careful that this object is not managed by the by Python, by the Django. It's related to the table claim, and it's managed false because it's actually created by the .NET framework that we are still compatible with. You will see some definitions here about the various codes. In Django 3 you can have these as an enum, which was not possible in Django 2. We have some methods over here. The getQuerySet method is used for the security. So you can see that one of the parameters we defined in the environment, the row security, allows you to actually query everything, but otherwise you are limited to what you can see. This is used for every method, being REST or GraphQL or any other kind of access. Now the GraphQL itself, we have the queries here, and this is dynamically loaded by the Backend Py module. It will go through all the modules and find the GraphQL definitions. It will actually load the schema.py that itself will have query and mutation. So here in the queries we have we can just use a simple query. We can use a Django filter connection field, which is going to use just a number of filter on the object itself, or you can just have for resolve claims we have a specific code to query as with the parameter that we want. In this, so if we come to the queries, we have the various objects that we are exposing. These correspond exactly to what we have in the documentation from the web, from GraphQL. And we have, for every object, we say is based on a model. So this one is based on the officer. We exclude the row ID field. This one is a binary and it's not properly exposing on GraphQL. We have an interface, meaning that we have a GraphQL relay node, meaning that we have paging with the edges and node as we have seen before. And these are the fields that you can use to filter. So if I go to specifically the claim GraphQL type, here I have the list of search that I can do. This one is actually getting the data from the diagnostics, from the claim admin, from the health facility, and including them with this prefix into this one. So if we want to add the category search, we can just add category, and you need to specify, because this is an automatic filtering system, we can say which kind of search we want. So we can say we want an exact search, or we want to have, for example, an iExact. Or if we can just specify iExact, and doesn't matter if it's lowercase or uppercase. So now if I save this, you can see that the server is automatically updating. And if I switch back here, if I can refresh, so that it fetches the schema again. It takes a bit of time because it's a large JSON description and needs to parse this. If I do I go to the query and claims, query.claims, and now we should be able to see that we have a category iExact. So now if I'm doing category iExact, and I can see I want a lowercase v, and I can see that we have the uppercase v that is found. So this is really a very good way to add data or to upload and to expose it, because we can have a lot of items that are defined in every module, and there is no dependency between the modules. You can see that here we are using this this reference to this other object, but we don't really need it to expose an object if it's not really if there is a link. So if for the injury link, There is nothing that we need to define. It will find that by itself that there is an inquiry object and that there is somewhere an inquiry GQL type that exposes it. So if you want to add, let's say for example, an identity card for the inquiry, and you have a link to that inquiry ID card somewhere, it will just be seen. And from the ID card, if you mention an inquiry, it will be exposed as a link as well. Now there's also the mutations. So the mutations are a bit more complex, or to use at least. And every time these mutations actually can be run asynchronously. So what it's going to do is call this mutation. So there's they all depend on openIMIS mutation. What openIMIS mutation is going to do is to save the request from this mutation to a database table, and then run asynchronously or synchronously, depending on the parameters, the query. But it's going to return immediately that it ran the query and give the ID of the mutation saved into the database. And you have this, and then it's going to call this async mutate. There is the verification of the authority of this person, the authorization of this person, and then you do the actual operation. In this case, it's going to call the service update or create claim. Now, if we want to create a new module completely, what we can do is go back to the README to create a new openIMIS module. What are we going to do? We need to create a directory next to the other modules with a subdirectory named as your module logical name. So in this case, we're going to have my module pi. So we switch to the command, and we're going to make this folder openIMIS backend. We're going to call it video. And we are going to create a subdirectory video, just as we have here. Then from openIMIS, we need to create a skeleton module. So we need to do the Python manage startup my module, and with this pass. So let's go back to openIMIS, backend, pi, openIMIS, Python manage. We'll call it video/video. Didn't happen much. Prepare your module to be mounted by pip. So we need to create and complete this setup.py. So now if we go back to the environment, we can close this, and we have the video here. And we see that we have the various samples of the application that are here. So what we can do is just copy from another one. So if we copy from the claim, we can copy the setup, readme, license, manifest, GraphQL public license. So here in the setup.py that we just created, we need to adapt it, of course. It's not a claim, it's video. It's version 1.0.0. File packages, openIMIS, backend, video, sample module. Author, in this case, would be me. We have the requirements from this module. Well, in this case, we can just leave it, but not much. This version from this video is 2.1 because we are working for the master branch, but in the main version, it should be a version 3 of Django. There are only minor differences. The README, of course, will have to be adapted. So backend, just do backend video module, and in this case I can just remove everything and say this is a sample. Now this is okay. Go back to this one. Every openIMIS module must provide its URL pattern if it's empty. So we need to create the file urls.py with the content URL equals yes. So there are no URLs here. So create the file urls.py, and I just say URL patterns equals that. Now that we have this, we can register this to install in pip. Just make sure that we have the right module. And now we need to register the module also in the openIMIS.json, because otherwise it's not going to be loaded. openIMIS.json. I'm going to copy one. So we're going to copy this one. I'm going to call it video. It's claim batch. No, it's called video, and it's 100. There we go. Start it again. And that is running. Now, from here, your local openIMIS has added the new module directly loaded from your directory. Now let's try it. If I decide to add a new model, if I create a new model here, I can create a class video with a capital V, video. That's models. Oh. And I'm going to have a member that is video name equals models.text field, and I'll make the kill mandatory and everything. I'll just leave it like this. So now that we have this object, we need to run a migrate. We can run it from the command line, or we can just create a configuration for this, so we can just duplicate the run server. Just say run make migrations, make migrations. I can just run this, and here it created a file initial.py that contains the creation of this model. So we need to also migrate it, so we're going to duplicate it again and just say, in this case, migrate. And this is creating the actual table. So now that we want to expose it, we need to create a schema file. So what should this schema file contain? So if we look at the claim, which is a complex example, but it still contains everything we need. We will need to have these query, and we'll have to also specify the order Django filter connection field, for example. I just copy this. And I'll go over here. So you can see that we don't have graphene yet, so we can just do an Alt-Enter to import graphene. Same, import this one. Here we don't have the claim GQL type, but we will create this type. So here we would say video GQL type. Doesn't exist yet. And we have the order by here. It's graphene list of type graphene string. So that's a list of sort fields that we have. Now we need to create the video GQL type. So again, if we look for a sample here in the GQL queries, we see that the GQL types are simply objects that contain here a class meta, exclude fields, interfaces, and filters. So we don't need these. Come back here, and we just add it on top. So the Django object type that we need, it's not a claim, it's a video. This normally should be completed with the detailed documentation. So in this case, we want to expose these these additional items, but if we just have this, we can just do just video. We need to import from the model. So the filter fields will be by name. We have the exact field. The others we have nothing else. We have an extended connection. The extended connection is used for the order by and other such things. And voila, normally we should have into this definition. If you refresh this, we have this error because we specified video name and not name, so we just change to video name here. Just refresh it. And we see that the videos was added here. So now we can do a search on videos, and we can search by name, video name. We have nothing, of course, so it's not gonna work. Here we have the name, video name, and the ID. And we have, of course, no data over here. Now, if you want to add a new a mutation in this case, we can also check the schema over here and see that there's a mutation class. It's going to see the claim mutation the field. So we're going to go back to our own schema. We're putting everything together so that it's easier. And then we'll have our mutation. So we have a create video. Of course, you see here we have nothing to, we have no mutation yet. So let's see what the mutation looks like. So it's based on openIMIS mutation, and it has a module and a class. This one is used for the names that we are going to use in the asynchronous mutation, so that it knows which one to use. Then it's going to define what kind of input it's going to use. In this case, we have an input type we have to use. So let's first do that. So the input type is a graphene list in this case, but we want a graphene.field. It's going to be text, graphene string. So we just specify the input type coming from this one is claim input type, but we should have an openIMIS input, mutation input. So in our video, let's do the input type, class, create video input type. It's going to in openIMIS mutation so this one is not yet imported, just imported, and we want to say the video name equals graphene string acquired equals true in this case. And we have another create video mutation. It's going to import from openIMIS mutation. I know it. So now we need to get the various items from the openIMIS mutation, from the mutation. So we're going to inherit from openIMIS mutation. In this case, we have the input that is coming from this external object, and we have this async mutate. It's going to be run. Create video input type. There's nothing in there because it's inheriting from there. We have the async mutate. The async mutate is going to do the actual mutation. So here we can we just skip the user validation. You can see on the others how it's done. In this case, we're going to say that we want video.objects video. So here we want to do video.objects.create with the video name being the video name. So since we want to make sure that it's running, we're going to put a breakpoint. So we forgot to provide the create video mutation dot field in this case. Let's just save, updating the server. Now I should be able to refresh this. Schema is loading. If we look at the mutations, we can see that we have a create video mutation, and there's a create mutation, there's an input. So now to do a create video mutation, to create the mutation, we're going to create mutation here. Then we do create video. We're going to provide it an input. In this case, we don't provide the same independent fields. We provide one input field that is a JSON object that contains various information, especially in this case the video name. So the video name will be this one. We can also provide, as you can see, other items. So the client mutation label allows us to provide some information that will be retrieved with the additional mutations. So client mutation label, for example, that will be label. Now that we have done this, you can see that there's still an error because we want to say what we're going to get as a result. So let's predify this. We want to see what kind of result we want from this. So in this case, what we can have is the internal ID and the client mutation ID. Now let's run that. We have here the breakpoint that is triggered. and we received an internal ID from this mutation. So what we can do is to check what the mutations are. So if we do a query on mutation logs, and we can have the internal ID, for example, we can just use for the moment as usual. Then we have the ID, the client mutation ID, client mutation label. We have the status, request date time. You can see that we have one such request and status 2. So it was actually executed properly. Now if we query the videos again, so now if we query the mutation again, the video again, just say videos. Of course these are not provided anymore. We have video name, and we can see that we have one video created. So we added a new module, we created a new model, we exposed it on the queries, and we made a mutation for this model. Let's summarize what we just learned. We saw how to download modules, how to set up a development server, how to set up the development environment, how to load an existing module like the claims, to create a new module and install new data models. So you have all the basic tools to get started with the openIMIS development. So what's coming in the next videos? First of all will be the access rights. We'll have the module dependencies, including the events between the various modules. We have the internationalization. We have the testing, the batch processing, and how to generate PDF reports. See you!